Welcome viewers, in this video we will see the 8:1 multiplexer. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic 8:1 multiplexer. The multiplexer is nothing but many input into one output digital logic circuit. That is 2 to the power n is to 1. That is 2 to the power n input and only one output with the n number of selection lines. So out of 2 to the power n, only one output is available, that is decided by the selection line. So here we have the n equal to 4. 2 to the power 4 is to 1, that is 2 to the power 4 means, so here the n is 3, not 4, n is 3. 2 to the power 3 means 8 is to 1 and 3 selection lines are available, right? So 8 inputs, only one output. This 8 output, out of 8 output, only one output available at the, out of 8 input, only one output available at the output side. So that is decided by the 3 selection line. These 3 selection line will decide which input is available at the output, right? So we have 8 input lines, only one output line and 3 selection lines. So that is given here. There are 8 input lines and 1 output line and 3 selection lines. As shown in the table, the selection line, a particular input line is controlled by the 3 selection lines, right? The inputs are controlled by selection lines. Now we'll see the block diagram and truth table, then we'll go to the logic diagram. So this is the block diagram, 8:1 multiplexer. There are 8 inputs are available, 0, 1, 2, 3, 4, 5, 6, 7. That is nothing but D0, D1, D2, D3, D4, D5, D6 and D7, and only one output. Out of 8 input, only one output will be available at the output side. This is the enable input. If the enable input is given, then only the circuit will work. If the enable input is 0, the output will be 0. So out of 8, only one input, out of 8 input, only one output available, that is decided by these 3 selection lines. These 3 selection lines will control which input should be available at the output. Now we will see the truth table. So this is the selection lines, S2, S1 and S0. This is the output. So D0 to D7 is available at the output. These are all the 7. These are all the 8 inputs that is available at the output. So the selection line 0, so selection line 3 lines are available, S0, S1, S2. Because of 3 we have 8 combinations are available, so that 8 inputs are controlled. 0, 0, 0 means D1 will be available at the output. We will see the logic diagram, how 0, 0, 0 means D1 is available at the output. We will see with the detail in the logic diagram. 0, 0, 1 means D1 will be available at the output. 0, 1, 0 means D2 will be available at the output. 0, 1, 1 means D3 will be available. 1, 0, 0 means D4 will be available at the output. 1, 0, 1 means D5 will be available at the output. 1, 1, 0 means D6 will be available at the output. 1, 1, 1 means D7 will be available at the output, right? So which input should be available at the output is based on the selection line, 8 different combinations. These 8 different combinations will decide out of 8 which is available at the output, right? So we'll see the logic diagram. We'll verify this in this logic diagram. If it is 0, 0, 0, how we are getting D0 as a output. Similarly 1, 1, 1 means how we are getting D0 as a output. So we'll verify all these 8 combination in the logic diagram. So this is the logic diagram available. So what we have, there are 8 AND gates are available. Because of 8 input, the 8 AND gates are available, right? So in this 8 AND gate, one of the input is D0, data line. Another input is the enable line. If enable is 1, then only the circuit will work. Enable is 0, the output will be 0. Because here the AND gate, any one of the input is 0 means totally 0. So the enable should be 1, right? So the one input is data line, D0. Second input is the enable input. Another 3 input is nothing but the selection line, S0, S1, S2, right? How the selection lines are connected, we'll see that. Before that, we'll see all the AND gate. The first AND gate, D1 is connected. Second AND gate, D0 is connected. The second AND gate D1 is connected. The third AND gate D2 is connected. In fourth AND gate D4 is connected. In all, enable is already connected. Then in the fifth AND gate D4 is connected. In the sixth AND gate D5 is connected. In the seventh AND gate D6 is connected. In the eighth AND gate D7 is connected. Right. So in this 8 AND gate, all 8 inputs are one by one it is connected, starting from D0 to D7, and enable also connected in the all the AND gates. So all these AND gates are connected by the OR gate, right. So all these 8 output is added by this OR gate, and the totally we have only one output. Now we will see the selection line. That is very important, how the selection lines are connected. So these are all the 3 selection lines, S0, S1, S2. From S0 tapping is taken, that is connected to one NOT gate, so that we got S0 dash. S1 tapping is taken, is connected to NOT gate, so that we got S1 dash. Similarly in S2 tapping is taken, connected to NOT gate, so that we got S2 dash. So we have S0, S1, S2, and also S0 dash, S1 dash, S2 dash. So there are 6 possible inputs are available. Out of 6 possible, it is connected according to our requirement. That is 0, 0, 0, 0, 0, 1, 1, 0, 1. Like that, there are 8 combinations are there. According to this 8 combination, the selection lines are connected to these 8 AND gates. Now we will see how it is connected one by one, and also how you control the out of 8 input, how the particular input is available at the output, right. So in the AND gate, one input is data line, second input is enable, remaining 3 inputs are selection lines. Selection lines are connected in particular way that it will control the given input. So totally there are 5 inputs are available in the AND gate. Now we will see this AND gate one by one. We will go to the first AND gate. So in the first AND gate, the D0 is connected, enable is connected. Enable is already 1, always 1, it is enabled. See how it is connected, S2 dash, S1 dash and S0 dash. The first AND gate is connected with the complement, not connected S1, S2, is S2 dash, S1 dash, S0 dash. In the truth table we already discussed, if it is 0, 0, 0, for the 0, 0, 0 we are getting the D0 as a output. How it is possible? 0, 0 means, you see this, all are 0, but S0 is 0, S0 dash will be 1. Similarly, S1 is 0, so that S1 dash will be 1. S2 is 0, so that S2 dash will be 1. See that? So 0, 0, 0, it is connected with the complement, so that automatically it become 1, right? It is also 1, second input also 1, third input also 1, right? So already D0 is available, E is already 1. See these 3 control input also now become 1, because 0, 0 combination, it is connected with the complement. So automatically these 3 zeros are become 1, right? Now all are 1, all 4 inputs are 1. So this D0 will be available at the output. If the D0 is 0, the output will be 0. D0 is 1, the output will be 1, right? So all out of 5 inputs, 4 inputs are now become 1, so that automatically D0 will be available at the output. So for the 0, 0 combination, what will happen to the other AND gate? See this 0, 0, 0, right? Thus these two 0 become 1, 0, 0 because of complement, but this S0 is 0 only. So one input is 0. So totally the output will be 0. Similarly, this S1 is 0. So I am explaining about this, right? When S0 is 0, S1 is 0, S2 is 0, what will happen? Here S1 is 0. So totally the output of this AND gate is 0. Similarly, here S1 also 0, S2 also 0. So this output of this AND gate is 0, right? So for this combination 0, 0, 0, only the first AND gate will produce the input D0. Remaining all AND gates are automatically become 0. Any one of the input, at least any one of the input is 0. So the totally the output is 0 in the remaining AND gates, right? So, okay. Now we'll discuss 0 0. Now we'll go to the 0 0 1 combination. Second one is 0 0 1 combination. For that we are getting D1. That is what we discussed in the truth table. See this is 1. S0 is 1. S1 is 0. So that S1 bar become 1. S2 is 0. So that S2 bar become 1. See this all become 1. So the selection lines are connected in such a way that automatically it become 1. So that we are getting the corresponding output. Enable is already 1. So that automatically D1 is available at the output, right? 0 0 0 1 is given, but because of this connection S2 bar, S1 bar and S0 is connected to this AND gate. So automatically 0 0 1 become 1 1 1, right? 3 inputs are 1, enable also 1 means automatically D1 is available at the output, right? I will go to the third one. Here 0 1 0, third combination 0 1 0 is given, right? 0 means this become 1. This is already 1. This is 0 means S0 bar become 1. See this now all become 1 because of complement. 0 1 0 become 1 1 1. Enable is already 1, so automatically we will get D2 as the output, right? Then fourth one 0 0 1 1, right? The fourth one, this is 0, first one is 0, so that S2 bar become 1. Already S1 and S0 are already 1, so all are 1, so automatically D3 as a output, right? See this, the combinations are connected in such a way that automatically it become 1 and the remaining AND gates are automatically become 0, right? Now we'll go to the fifth combination. So this fourth combination over. Now we'll go to this. Fourth one is 1 0 0, right? 1 0 0 means this is 1. These two are complements, so that 0 0 become 1 also, right? 1 0 0 now become 1 1 1 because of these two complements. So that D0 will be available at the output, right? The next one 1 0 1, next combination 1 0 1 means the second 0 here the complement is there, so it become 1 1 1, right? So automatically 3 inputs are there, so the D5 will be available at the output, right? That was what is the next one 1 1 0, right? This 1 1 0 because of this complement this also become 1, so automatically D6 is available at the output, right? The last one is 1 1 1, all are already 1, so automatically D7 will be available. So the important thing is the selection lines are connected in such a way that for this truth table what we discuss automatically it become 1. For example, the first combination is 0 0 0, we are getting D0. For 0 0 0 we are connecting the selection line as S2 bar, S1 bar and S0 bar, right? So for the 0 0 0 is the input, the selection line, but it is connected with the complement, so automatically it become 1 1 1, so that D0 is available at the output. Similarly other combinations, right? So automatically it become 1 such a way that the selection lines are connected, either S0 or S0 bar, S1 or S1 bar, S0 or S1 S0 bar, right? For this, see this example, see S2 S1 S0 bar, here 1 1 0, this 0 automatically become 1 because of complement, so that such a way that it is connected, right? See these are outputs are summed by this AND gate and it will produce only one output, right? So this is, these three inputs are 1 mean remaining AND gates are automatically 0. For example, these are all 1, but see this S0 bar, S0 is 1 mean S0 bar will be 0, so automatically like that other AND gates are become 0, other AND gates will produce the 0 output, right? So in this video we discuss 8:1 multiplexer, 8 input into 1 output. We discussed the block diagram and the truth table. Based on the truth table, the logic diagram is explained. The logic diagram we have 8 AND gates and that are all connected to the one OR gate. In the 8 AND gate, the one input is enable, another input is data line. The remaining 3 inputs are selection lines, totally 5 inputs. The enable is always 1, the data line is available. Based on the selection line, the particular data line input is available at the output. For that we have 8 combination we discussed with the truth table along with the logic diagram. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.